Hello again, this is Mr. Trink. We're going to look at solving systems of equations by elimination, and we're going to do 3 examples of that. Hopefully at the end of it you have a good grasp of what it is that we're trying to do. So let's move on to the first example. We have 2 equations here. The thing to note is how they are arranged on the page, and they've already been lined up, so the x's, the y's, and whatever constants there happen to be are all vertically lined up, as well as the equal sign are all vertically lined up. This is an important step that you need to take before you go about trying to actually solve by elimination. So I'm not going to show you how to rearrange an equation at this point, but know that this is where I'm expecting you to be starting from when you're doing an elimination. Now, the numbers don't have to be, or the variables and the constants don't have to be exactly like this. We could have the y's in the first column, then the x's, then the constant, then equals 0 or something like that. But both equations need to be lined up the same. X's, y's, and constants. Okay, so let us start off as usual by numbering our equations, and this is going to help us to keep track of our equations. When we have elimination questions that are more complicated, this is going to become critical. Now, what we're looking at for elimination is finding a variable. In this case we have x's and y, so we're looking for either x or y where the coefficient of the x's or the y's have the same magnitude. So like 2 and -2 have the same magnitude, 1 and -1, 3 and -3. If we have 2 variables with the coefficients of the same magnitude, as we do here for the y variables, one is a -1, one is a +1, same magnitude, opposite signs, what we're going to do is add the 2 equations together piecewise, and in doing so the variable that has the matching magnitude coefficient is going to be eliminated. We'll be able to solve for the remaining variable and then substitute back in to find the variable that we eliminated originally. Now, if we don't have the case where either the x's or the y's have the same magnitude, then we're going to have to do a little something more complicated. First 2 examples are going to be easy. The third example we're going to have to do that. So here we look at our 2 equations, we number them, we identify that the y's are primed for elimination, and what we're going to do is combine equation 1 and equation 2 with the operation of addition. So I'm going to take equation 1 plus equation 2, and I'm going to add piecewise. So vertically in columns, applying the addition operation to each of the pairs. So 2x plus 3x is going to give me 5x, -y plus y is going to be 0y, I'm not going to bother writing that, and 5 plus 15 is going to give me 20. I can now divide both sides by 5, and I'm going to get x equals 4. At this point, I've solved for one of the variables, and I can go ahead and substitute into either of the 2 equations to solve for y. So I'm going to sub x equals 4 into, doesn't really matter which equation we substitute into. I'm going to substitute into equation 1. So I'm going to have 2 times x, which is now 4. Just 1 second. Okay. And I'm going to substitute into parentheses to remind myself that I need to multiply by the coefficient, and that is minus y equals 5. Now I'm going to solve for y in this equation. So I'm going to get 8 minus 5 equals y. So what I did was I moved this minus y, added y to both sides, so I have positive y on the right hand side, subtracted 5 from both sides. So now I have 8 minus 5, 2 times 4 is giving me this 8 here. So I'm going to get y equals 3. Therefore, the solution is 4, 3. Okay, and you want to make sure that you give a concluding statement with the solution as an ordered pair, making sure you remember the parentheses. Okay, that was fairly straightforward. We're going to go through the next one a little faster. So again, we're going to start off by numbering our two equations, equation 1 and equation 2. I'm going to look at my two equations. Do I have any variables with the same magnitude coefficient? Yes, the x's both have 1s in front of them, both positive 1. So to eliminate the x's, I'm going to have to subtract the two equations. So I'm going to perform piecewise subtraction. So I have equation 1 minus equation 2. You could do equation 2 minus equation 1. If you did that, it would actually work out a little better in this case, but it really doesn't matter. The important thing is that we've eliminated one of the variables. We've eliminated the x. So x minus x is 0x. I don't need to write that. Negative 4y minus 5y is negative 9y, and that's going to equal 3 minus negative 24, which is going to give me positive 27. Remember, we're applying the subtraction operation, so I have 3 minus negative 24, which is 3 plus 24, gives me positive 27. I'm going to divide both sides by negative 9, and I'm going to get y equals negative 3. I can now sub y equals negative 3 into, it really doesn't matter which equation we use. I'm going to sub into equation 1 because I just don't care, and it's the first one. So I now have x minus 4 times negative 3, substituting for the value y with negative 3, and I'm going to put that in parentheses, and that equals 3. So I have x plus 12, or minus negative 12, which I can rewrite as plus 12, equals 3. So x equals negative 9. And that's a terrible negative 9, so I'm going to try to fix that. I'm not that great at writing with this thing yet. Will improve, I'm sure. So negative 9. Therefore, negative 9 comma negative 3 is the solution. Okay, so we're done with that one. Same magnitude, same sign. We subtract, solve for a variable, substitute that into one of the equations, solve for the other variable, give the answer. Let's move on to the next one. It's going to require a little more work. So let's start out by numbering our equations. So I have equation 1 and I have equation 2. I'm looking to find two variables, either x's or y's, which have the same magnitude. In this case, none of them do. So what I actually need to do is multiply each equation by something in order to make sure that I have the same magnitude for either the coefficients of the x or the y. I look at the x's here. I'm going to eliminate the x's. I could just as easily eliminate the y's. It really doesn't matter. Well, you know what? The previous two we eliminated the x's, I think. Let me just flip back for a second. Nah, we didn't. Let's eliminate the y's. Why not? Okay, so what I need to do is think of a number that I can multiply equation 1 by, and think of a different number that I can multiply equation 2 by, so that the coefficients of the y's are going to be equal to each other. So I look at these, and they are coprime, meaning that they have no factors in common. So what I actually have to do in this case is multiply the first equation by 8 and the second equation by 3. So I'm going to go ahead and do that. I'm going to write it like this. I'm going to take my first equation, equation 1, multiplied by 8, and I'm also going to take equation 2 multiplied by 3, and writing down my steps like this makes it easy to explain later, and easy for other people who are reading your solution to know what it is exactly you did. So I'm going to multiply this first equation by 8 each component. So 4x times 8 is going to give me 32x. 8 times negative 3, or minus 3, so I'm going to get minus 24y is equal to 8 times 25, so 4 times 25 is 100, so it's going to be 200. And I'm going to multiply equation 2 by 3, so I'm going to multiply this negative 3x by 3, and that's going to give me negative 12, negative 9. Watch your times tables here, of course, as always. Negative 9x, and that's going to be plus 24y, and that's going to equal 30. Now what I'm going to do is number these two new equations, 3 and 4. And again, that's just going to make it a lot easier to see what I'm doing. And now I'm going to add these two equations together because my y's have the same magnitude with different signs. So I'm going to take equation 3 plus equation 4. Okay, so I have essentially positive 32x plus negative 9x, or 32 minus 9. So that's going to give me 23x. My y's are going to cancel, and that is going to equal 230. And 23x equals 230. I can simplify this, solve for the x by dividing by the coefficient in front of the x, and I'm going to get x equals 10. I can now sub x equals 10 into, it really doesn't matter which one. Let's substitute into equation 2 this time, just why not? So negative 3 times 10 plus 8y is equal to 10. So I have negative 30 plus 8y equals 10. 8y equals 40. So y is equal to 5. You don't necessarily have to show the division all the time. So like here I showed the divided by 23, but you can just divide it and give the answer. So therefore the solution is, and I just write my solution as an ordered pair, 10, comma 5, and I write that in the parentheses as always. I apologize for the messiness of my writing. I'm assuming it'll get better as the semester progresses. Anyway, I hope that helped, and thanks for watching.